Okay, here we go. We're going to be focusing today on writing equations of lines when we're given information about other lines that are parallel or perpendicular to it. So for this first problem, it says write a line that is parallel to y equals 1/4 x and has a y-intercept of 7. The first thing we want to remind ourselves is that if we draw two lines that are parallel, we see that they'll never meet. And the reason why they will never meet is because they have the exact same slope. And so we know parallel lines have the same slope. So what I have taught is I've taught my class to write the old equation, to use the word old. It's really our given equation. So they gave us an old equation and they're asking us from that old equation to write a new one. And they're giving us hints about how to write the new one. First of all, they gave us the hint that our new line is going to be parallel to this line right here. And when we look at that line, we look for its slope. And its slope, of course, is right before the x. So the old slope is 1/4. The old slope is 1/4. Well, our new line is parallel to this old line. So our new line will also have the slope of 1/4. I tell my class we're going to steal the slope from the old one. So that we're going to steal it, we're going to use it for our new line, and then guess what we're going to do with the rest of the old equation? We're going to get rid of it. We're not even going to look at it anymore. We steal the slope, and we're done with that old equation. So now we're going to figure out what else to write for our new equation. So we've got the slope is 1/4, and of course we put the x next to it. And then it tells me, I'll go back into the problem, it says write a line that's parallel to y equals 1/4 x. Good, we stole the slope and we used it. And has a y-intercept of 7. And I know that I can put my y-intercept there. So this is our answer. This is our new equation given what they gave us. Now you're going to see 6 different types of these problems on the test, and this is one of the types. So it's a good thing to be exposed to all the different types. This next one, oh my goodness, look at the old equation. Let's write it down. They gave me this old line, and it is y minus 5 equals 3 times x minus 2. And from that old line, we are going to write a new line. So we're going to use the information from the old line and the other information in the problem to write a new line, a new equation. So this is not a very pretty equation right here, the old one. And so when we look at it, all we really want to know is what is the slope? I mean, I could add 5 to both sides and make it look a little bit better. I could distribute, but you know what? I know from experience that this number right here is my slope. Yeah, we could rewrite it, but I don't want you getting caught up on that. When you see an equation in this form, know that the number right before the parenthesis and the x, right? Because this is really like in the form x minus h, but instead of our k being over here, it's over here. So we'd have to move it if we wanted to make sense from it. But we know this is our slope. So if our old slope is 3 and the new line is parallel to our old line, then it means that our new line also has the slope of 3. So I'll write y equals 3x, and I'm almost done, right? Not quite. So I stole the slope, I stole it, and then I'm done with it. I'm not going to look back at the old equation again. So I'm going to backtrack of how I did this. My new line, I'm going to write the information. I stole the slope, so the slope is 3. And then I'm going to look at what else they gave me. Okay, that's the old line. We're done with it. But they gave me a point, the 0.73. And so now we're going to do what we've been doing for days and days and days. And that is we're going to use the long equation. We also know it as the point slope equation, but it's the long equation that looks like this. Do you have to memorize it? Yes, you have to memorize it, but you've used it so much that I think you've got it. So what we're going to do is we're going to plug in our 3 for m, we're going to plug in our 7 for h, and our 3 for k. And you guys are pretty good at this. So we're going to go ahead and plug them in. but then we're going to continue working so that we can get this into slope-intercept form, our y equals mx plus b form. So here we go. We're going to distribute, and you guys do that well. Sometimes you guys forget to distribute to the second one. 3 times negative 7 is negative 21, and then we bring down this plus 3. We just bring it down like that. Then our very last step is we're going to combine these like terms. Negative 21 plus 3 is what? Negative 18. Does that sound good? Okay. And here's the new equation that is parallel to the old line and goes through the point 7,3. If this doesn't make sense, you feel free to pause it, kind of think about it, rewind it, pull it back, hear it again. But you will see one just like this on the test. Of course, different numbers, because we want to get you prepared, but we don't want to cheat. That wouldn't work. So this number 3 is a little bit different, and you'll see something like this on the test as well. Given the line x equals 0, okay, that's our old line. So we're going to write old line. Our old equation is x equals 0. But then I look at the old line, and I'm like, well, wait a minute. I don't even see a slope. So this isn't going to be helpful. And I don't even see a y. If it were y equals a number, we would know the slope is 0. But we know what x equals a number looks like. It's a straight up and down graph, isn't it? And if it's straight up and down, our slope can't be determined. Our slope is undefined. So let's go ahead and do a little sketch of what x equals 0 looks like. First of all, we go to the x-axis and we find the number that's on this side. We find the 0. There it is. And then we have to draw a line straight up and down. All right, this is kind of a goofy problem, but it's important to understand. If we draw a line straight up and down through x equals 0, we get the y-axis. So please don't let that bother you. Let's just focus on that we have a straight up and down line that goes through 0. Okay, so I use the information from the old, and I'm done with it. I graphed it. I'm not going to look back. So now I'm going to look at what else they gave me. Well, let's see. They gave me, okay, done with that. They gave me a point, negative 2, 8. So this problem, note, we're not doing any of the equations or any of that stuff. We're actually using the graph to help us. So we're going to plot negative 2, 8. Now, be careful when you are graphing a point. I know we've gotten so used to 1, 2, 3, 4, 5. Oops, I'm going to have to extend this. 6, 7, 8. Okay, we've gotten so used to doing slope, where slope is rise over run. Sometimes when we go to plot a point, we get confused about which one we do first. So when we have the line negative 2, 8, when we have the point negative 2, 8, remember, x matches up with the negative 2 and y matches up with the 8. So we start from the origin. Let me switch my color. So we start from the origin, and negative 2, 8, the point negative 2, 8 says go over 2 for the x-axis and then go up 8. And you're right up there. That's the point. And so let's think about what the question's asking us. It's saying find a line, a new line, that's parallel to the old line that also goes to this point right here that we just graphed. Well, I know then that my new line has to go straight up and down, because then, oops, I missed my mark there. Let me try that again. I know this line has to go straight up and down because it has to be parallel to our old line, the red line. And I know it has to go through this point. So what line did I just draw? This line right here, the name of this line is x equals negative 2. And that's our answer. So this problem was different because we didn't write down equations, we didn't do any distributive property, we just used the graph. Now, some people have noticed that there's a little shortcut here. I don't mind if you can understand the shortcut that you use it. They say, well, wait a minute, Miss Overby, if I know that the x is straight up and down, and so x equals 0, the line x equals 0 is straight up and down, and I know I'm going to seek another one that's straight up and down, then really all I'm going to do when I see x equals 0 and I'm trying to find a parallel one, I'm just going to go, well, of course, it's x equals negative 2. Now, that may or may not make sense to you. Don't use it if it doesn't make sense, because that means you probably won't use it correctly. All right, so halfway done. Let's look at the next type. This next type you'll also see on the test. Yes, this is a long test, but you are going to be prepared because you're going to keep practicing and practicing like on problems like these. So write an equation of a line that passes through 4, -5 and is perpendicular, so not parallel, perpendicular to the line y equals 4x plus 2. Let's use what we've been doing before, and let's write the old line. They gave me a line. This is the old line, not our new line. This is the old line. Okay? And we're going to remind ourselves that we are looking to find the equation of a new line. So we're going to look at the old line, and just like with the parallel lines, we're going to steal the slope. Okay? So we're going to steal the slope. I see you, slope. You're 4. I'm taking you with me. So for my new line, okay, it's not really 4, but I'm going to show you what else we're going to do. So we steal the slope, but we're not done there. Okay? We steal the slope, then we make it into a fraction. Then we flip the fraction. Then we change the sign. If our slope is positive, like it is now, our new slope is negative. If our slope is negative, it changes to positive. I know, it's a lot. And hopefully you have your study guide that you've got that down. If you want to write it down here, we can rewrite it. Basically, you're going to steal the slope. Steal the slope, just like we did with parallel lines. The second step is make it a fraction. So if it's not a fraction, all you have to do, just like we did here, we turn 4 into a fraction by just putting a 1 underneath it. And then you're going to flip it. So we made it to the fraction 4/1. And the next step is we just flipped it. And the very last step is change the sign. So yeah, perpendiculars are a little bit harder than parallel, but we can do it. So once again, we have to be on the lookout to see that it says perpendicular and not parallel. So we stole the sign. We made it into we stole the slope. We made it into a fraction. We flipped it and we changed the sign. So now our new line has this slope. So we're almost good to go. All right, so we stole the slope. Guess what? We're done with the old line. We are not looking at it. We stole the slope and we're done with it. So let's also go ahead and get it out there. All right, let's look back at our problem. Write an equation of a line that passes through 4, -5. Ah, that's my point. So now I've got my, I dropped my marker. So now I've got for my new equation, I've got my slope equal to -1/4, and my point is 4, -5. Whenever I'm given a slope and a point, I'm going to use the point slope formula. In my class, I just say the long form. It's the long one. So we're going to go ahead and write it. Yes, we have it memorized because we've written it so many times. And we're going to remind ourselves that all we do now is plug in the slope, plug in that number for h and that number for k. So here we go. We've got -1/4 x minus 4 plus, I could write plus a -5. There's nothing wrong with that, but I'm just going to write a -5 because that's the more efficient way to do it. All right, so all I have to do now is distribute. I'm going to do -1/4 times x is -1/4 x. Then we're going to do -1/4 times -4. If you do that in your calculator, it's going to give you a 1. Now, sometimes I notice that people will go, okay, that's a 1, and they just go ahead and put the 1 there. You've got to, if your answer is positive, you've got to put that plus there. We've got to have something in between. And then we go ahead and bring down the -5. So here we go. We're going to combine our last two numbers. Trying to talk over the announcement here. Okay, so 1 minus 5 is -4. And there we go. We've got it. All right, so once again with perpendicular, it's a little bit tougher. We're stealing the slope, then we're making it into a fraction, flipping the fraction, and changing the sign. That gives us our new slope. And then we're using, once we get write down the point, once we get to this stage right here, then it's old news. all this stuff down here, old news. This is just what we've been doing time after time after time. Okay, so 4 down, 2 to go. You'll also see on the test something like this. Write an equation of a line that passes through the point 32 and is perpendicular to the line 4y equals 3x minus 1. It looks almost the same as the problem we just did. We see that they gave us a point, we see that it's perpendicular, not parallel, and we see the equation of an old line. So let's talk through this. Let's go ahead and write down the old line, what they gave us, the given line. The old line is 4y equals 3x. Please, please, please do not fall for this trick. I think they're trying to get us. What do you think? I think they're trying to have us say, oh, 3 is our slope. Yay, let's steal it. No, 3 is not our slope, so let's undo that. We only can decide what our slope is when y is all by itself. And right now, 4 is in the way. So we've got to get rid of 4. And we remember from last year in middle school when we solved equations, if something was being multiplied, the 4 and the y, there's really a multiplication sign that you don't see between them. So we're going to do the opposite to get rid of the 4. We're going to go ahead and divide by 4. And if we do that, we've got to divide every term by 4. And so what happens then is the 4's get canceled out. We cancel each other out, and we get y equals 3/4 x minus 1/4. So in this particular type of problem, we have to do some work to the old equation before we get to find the slope. So finally, now for our new equation, we're going to look at the old equation, and we're going to steal the slope. So I'm going to take this as the slope, 3/4. I'm stealing it. And when I steal it, am I done with the other one? Yes, no more old. I'm done, no more old. Don't look back at it. Just move on. But I stole the slope, which is 3/4, but that's not really the slope because it's perpendicular. If it was parallel, I would be done, right? Parallel, we just steal the slope and use it. Perpendicular, we steal the slope, we flip it. Oh, sorry, we got to skip something. We steal the slope. Usually we have to make it into a fraction, but it's already a fraction. So we go to the next step, which is flip it and change the sign. So this is my new slope. I know, it's a lot of work. I hear you. These problems, they're not quick to do, are they? And then they gave us the 0.32. So now I've got my new slope. I'll give myself some visual space here. I've got my point. What was 0.32? And now it's old news. I know this takes a lot of stamina, but we can do it. And actually, the more problems that you work through, the better your stamina, the better your endurance will be for these problems, and the better your endurance will be on the test. So we go ahead and write our old formula. I'm sorry, not our old formula, our long formula, our point slope formula. And we're just simply plugging in our values that we have. And we're going to do a lot of distributing. All right, so here we go. We're going to distribute. So we'll have y equals negative 3/4 x. And negative 3 times negative 3, I've got that as a plus 9/4. So let's see. I'm just going to go ahead and write 9/4. You guys can change that to a decimal. I don't have a calculator in front of me, so let's see. I'm going to rewrite this with a decimal because I think that will be easier for you guys to add to a 2. So I'll have a 2. So 4 goes into 9 2 times. 8 with 1 remaining. Bring the 0 down. That goes into, and I think that's right. If I'm wrong, sorry. All right, that makes sense that it would be to these announcements. Okay. So with the decimal now, we can go ahead and add it. There we go. And we're done. Lots and lots of work Okay, I'm hoping I can get done without another announcement interrupting me. And our last one, oh good, our last one is kind of a little bit more of a fun one. Here we see perpendicular, we see y equals 7, and we see a point. Okay, just like when we saw x equals 0, when we see y equals 7, I think the easiest way to go about this problem is to get a visual. So I'm going to look at the graph. I'm going to find y equals 7 on the graph. 1, 2, 3, 4, 5, 6, 7. So to graph y equals 7, remember I go to the y-axis. I I put a dot on the 7, and then, of course, y equals 7 is just a straight across line. Oh, why does y equals 7 look like this? Right? Can you see my arms going straight out? Now, we want to find a line that's perpendicular to that. And I should have stopped when we talked about perpendicular, but I'm assuming that everybody knows perpendicular lines look like this. Like the x-axis and the y-axis are perpendicular to each other. The wall and the floor, they're perpendicular to each other. The ceiling and the floor, the ceiling and the floor are parallel. Ceiling and the wall are perpendicular unless you're in my classroom where we have the vaulted ceilings. And that's another story. All right, so if I'm given this green line and I want to find something perpendicular to it, I know I'm going to go ahead and find something that's straight up and down. But I can't just do any straight up and down line. I have to do a straight up and down line that also passes through the point that they gave me, the -1, 9. So I'm going to go ahead once again and graph the -1, 9. This is where you need to remember that graphing a point is not the same as finding slope. Yes, slope is rise over run. We do the y first, then we do the x. But when we look at a point, it's always the x and then the y. So that's different. Please don't confuse that on the test. So we're going to graph it, -1, up 9. All right, so here's the deal. We've got to find a line that's perpendicular to the green line that also goes through this black point. And there we go. All right. Did not exactly go through where it should have. That's probably because I didn't do a good job in doing a point, but you get the picture. The line is going through x equals -1. In fact, that is the name. I'm sorry. Yep, that's the name of this line, x equals -1. Whew, that was a long time. I'm just going to check the time real quickly. Okay, 22 minutes. That wasn't bad. I have another practice you guys can do, but really, practice makes perfect. Thank you for sticking it out, working hard, and I know it's going to pan out. You're going to do great on your test. All right, see you in class.